Welcome, everybody. 大家好. I'm so pleased to see all of you here tonight. Thank you for joining us for the Bob and Kim Griffin Building U.S.-China Bridges lecture with Professor Tarun Khanna. For more than 4 decades, the University of Minnesota China Center has reflected the firm and longstanding commitment of the university to international research, teaching, and outreach. The Bob and Kim U.S.-China Building Bridges lecture is an example of this commitment to our mission. My heartfelt thanks to Bob and Kim for their tremendous support of the China Center. I would like to begin by introducing the Executive Vice President and Provost, Gretchen Ritter. Provost Ritter joined the university in late July. She's previously served as the inaugural Vice President for Civic Engagement and Education at Syracuse University. She also was a professor of political science in the Maxwell School of Citizenship and Public Affairs and a faculty affiliate in the Program for Advancement on Research on Conflict and Collaboration. She served as Vice Chancellor, Provost, and Chief Academic Officer at Syracuse University from 2021 to 2024. Prior to her time at Syracuse University, she also served in senior academic and administrative roles at the Ohio State University, Cornell University, and the University of Texas at Austin. An expert in both women's constitutional rights and democracy and citizenship in American politics, Provost Ritter's extensive research background is an asset to the University of Minnesota for navigating contemporary issues of higher education. We are delighted to welcome Provost Ritter to our lecture this evening and invite her to give some opening remarks.
Thank you so much, Joan, and good evening, everyone. I am so pleased to be here and to welcome all of you to the Building U.S.-China Bridges lecture. And I'm so pleased to hear about and learn about the tradition of this lecture and all of the good work that has happened in relation to our China Center. It is, of course, no doubt the case that we're in a moment where U.S.-China relations are somewhat fraught, somewhat fractured. Nonetheless, I think we all appreciate how incredibly important, perhaps this is the most important bilateral relationship in the world for many of the things that we all care about. And if we are to move forward on many of the important issues that face everyone in our world, beginning with learning and understanding is, of course, an incredibly key part of the path to identifying ways that we can work together. So for that reason and so many others, I am really glad to see you all here this evening to hear from our distinguished speaker. And I also want to simply say thank you to Bob and Kim Griffin for providing the funding and for their engagement and support, not only of this lecture, but of so much of the work of the China Center. And with that, I turn it over to our one of our faculty colleagues to introduce our speaker. Thank you.
Thank you, Provost Ritter. Before we begin the program, we want to let you know that there will be an opportunity for question and answers at the end of the program. There are note cards on your chairs. Please write your questions on them and hand them to the staff, and we'll share them with the speaker. At this time, I'm happy to introduce you to Professor and Dean Emerita of the Carlson School of Management, Shri Zahir. Professor Zahir became the 12th Dean of the Carlson School of Management at the University of Minnesota in March of 2012. She served in this role until July 2023. During her tenure as dean at the Carlson School, she oversaw the introduction of new degrees in business analytics, supply chain management, finance, and new programs in partnership with Tsinghua University in Beijing and Tongji University in Shanghai, to name a few. She is the current board chair of the Federal Reserve Bank of Minneapolis. Welcome, Professor Zahir. She'll introduce our speaker tonight.
Thank you, Joan, and good afternoon. And it is such a joy to welcome you all to the University of Minnesota's China Center for what promises to be a fascinating lecture on China and India's innovation systems. And it's an even greater joy for me to introduce someone who has been a dear friend to my husband, Professor Ak Zahir, whom some of you know, and me for over 30 years, and that's Professor Tarun Khanna. What you may not know is that Tarun's connection to the University of Minnesota goes all the way back to 1996. He showed up with his little sister in tow, and she had flown in straight from India, nervous, anxious, to start her MBA journey at the Carlson School of Management. And and it was a joy to have her here, and Ax and I got to play the role of the welcoming committee. And Tarun, even then, radiated the same mix of intellectual rigor, charm, warmth, and curiosity that you'll see from him today, and it has since become his trademark. And since those days, Tarun has gone on to become the Jorge Paulo Lehman Professor at the Harvard Business School, where he has taught since 1993, and where generations of students have been inspired by him to think about how entrepreneurship can really change societies. And as the inaugural director of the Harvard's Lakshmi Mittal and Family South Asia Institute, he built a platform that has brought together scholars, creators, policymakers, change makers across the world for over 15 years, and I hope we have a chance to hear from him about that as well. Well, Tarun's work has always been bold and ambitious, and at its essence, deeply, deeply human. His online course on entrepreneurship in emerging economies has reached nearly 1 million learners, proof that Tarun's classroom really is truly global. And his books and his research and his board service across the US and India and China all reflect a sort of a lifelong commitment, really, to enabling people to create, to innovate, and I think most importantly, to lift others up with them. And that's what he's been doing. And I'll tell you one story which captures the heart of who he is. Many, many years ago, Tarun told me that he spent so much time mentoring and guiding student ventures because he had a dream. And it was a rather audacious dream to create 100,000 jobs in India. And I thought to myself, 100,000 jobs? Only Tarun would set a goal like that and then, talk about it very casually over a cup of coffee, right? But then, since then, I've heard, I was listening to him today, he has created over 500,000 jobs, left that 100,000 goal far behind. And, he's, worked with Axelor Ventures in Bangalore. He's created India's largest chain of robot-powered chai cafes. Chai is the Indian masala tea, if you know what it is. And frankly, it's the only place in India where I know that I can get clean, hygienic, wonderful, tasty tea. So that's an achievement in itself. And he's also created the Aspire Institute, which provides free higher education services to literally millions of students in 190 plus countries. So I think it's fair to say that he didn't just meet that goal, he just kind of blew past it by a magnitude, and our world is so much better for it. So today we have the privilege of hearing from Tarun, bringing his unique cross-border lens to a topic which is at the heart of our global future, which is how two of the world's largest economies, most dynamic societies, India and China, they're innovating, they're diverging in some ways, but they're also intersecting and reshaping the possibilities of the 21st century. So with that, please join in welcoming a remarkable scholar and a longtime friend, both of the University of Minnesota and of ours, Professor Tarun Khanna.
Good evening, good afternoon. It's lovely to be here. Thank you so much for Shri for the very warm words. Not deserved, but I will aspire to live up to the glowing terms in which you were sweet enough to describe me. It's a privilege to be invited to deliver this lecture and to learn about the tradition of the Bob and Kim Griffin lecture series. It's really wonderful. As a comparativist at heart and someone who is quite passionate, I would say, about economic development and sort of morally indignant about inequities in the world, I feel that someone as blessed as myself to receive a good education and to be of some means should be spending their time doing something about pretty dramatic inequality that we see all around us. That's really what motivates me. I would say by training, I'm primarily an applied math person, masquerading as an engineer, masquerading as an economist. But in the end, the thing that I like the most are basically algorithms. And I try to look for ways to apply algorithms to solve social problems whenever an opportunity presents itself. When Joan invited me, Joan and Haya and the other colleagues invited me to give the China lecture, my first reaction was to say, I'm probably the wrong person. I'm not a China specialist. Actually, I'm not an India specialist either. I'm an applied math person. Maybe you're the wrong person. But I think the comparative flavor maybe will offer something, some insight. What I thought I'd do is focus my comments on, if you will, the scientific ecosystem in both countries that's emerging. China has, by many measures, and I'll share some of these with you, has eclipsed the United States already in terms of scientific achievements. In others, it's lagging. India is a bit further behind and may or may not catch up, but certainly is running a series of different experiments. And I think understanding the contours of those experiments and how they've played out is insightful for anybody in the world, really, whether you're operating in the city of Minneapolis, in New York City, or someplace in China or in India. So I hope that what I have to say would be generalizable in a way that I will try to make a bit clearer. What I thought I'd do is I'd motivate my comments first with some data, very high level, and some schematics and some pretty pictures, and then go into a couple of examples from China and a couple of examples from India. And that'll be what we have time for. And if I have time, I'll wrap it up with an example from New York City, just to show you that the ideas that I'm trying to put forward in these brief comments apply as much to Brooklyn, New York, and Detroit, and places like that. So that's the agenda. Let me try to tell you where I'm coming from. This is not meant to be a laundry list of what I've published or written. I just want you to understand where I'm coming from, because my background is a little bit atypical. People who know that I'm an entrepreneur and have built more than a dozen companies would not think of me as an academic. People who know me as an academic would not think of me as an entrepreneur. But I think it's doing the mix of things that works for me. Not advocating it for anybody, just saying that that's what works for me. To me, starting a company is like writing a research paper. It's extremely hard to get it right, extremely hard to make it work. Just like getting a paper published in the best journals is exceedingly hard to convince the referees. And they're both acts of inquiry, really, and ways of satiating my curiosity. So I started my fascination with China about 30 years ago, and worked very much with a political scientist who's now at MIT, Huang Yasheng, and we educated each other about China and India, and spent a lot of time. I was told by my friends in the tech team to look at that slide and not at that slide, something to do with the camera angle. So I'm going to be looking there, with apologies to this group here. So the book on the left, I started working on in the early 2000s. And it's really a first person, it's called Billions of Entrepreneurs. And it's a first person, almost like a, I hope, educated travelogue of going off the beaten path in both China and India and exploring the realities of the deepest villages in both countries, as well as sitting in the boardrooms and with the ministers in both countries and trying to form a view of how entrepreneurial ecosystems were building up. Fast forward another 25 years, the one on the right is a very abstruse exercise. It's an edited collection of essays, edited by me and by Michael Zonyi, who is a professor of Chinese history at Harvard. And we put together a collection of the leading philosophers, historians, economists, sociologists in China, India, and to some extent the United States. who had looked at the idea of meritocracy as an organizing principle of society. The notion of meritocracy and the notion of entrepreneurship, in my mind, are intrinsically interlinked, right? To be an entrepreneur and to succeed is an exercise in making meritocracy work in some ways. But that was a very interesting exercise. It lasted for 4 or 5 years, and we produced a volume that I'm sure not too many people will read. But I'm actually very, very pleased with it, mostly because it taught me a lot. And it made me go into the innermost sanctums of China one more time and engage with a very diverse collection of people, very different from the entrepreneurs I met the first time, particularly policymakers at the very highest levels of the CCP, the Chinese Communist Party, and Indian political classes, and so on and so forth. So those are sort of more like scholarly escapades. Sorry, I went the wrong way. I wrote a bunch of other books that all intersect with China in some ways. But the other diverse, so Shri was mentioning this chain of tea stores that I co-founded called Chai Point. It's the acronym in the bottom right. The reason I put these company names up there is that they're all intrinsically connected to China and to India, and so have each, like the academic papers, given me a lens through which to view and say what I'm saying to you this evening. Aspiring Minds was a software company that I built in 2008 with a colleague at MIT. Just two nerds writing code. But the idea was to find ways to locate talent in places that nobody looks for talent. So when you think about companies and they hire, they go, probably all the multinationals that are headquartered here come to the Carlson School, University of Minnesota, because it's where you go when you want local talent, right? But there must be tons of community colleges that are relatively less accessed. But there's no shortage of talent in those places. And I thought, why can't I write some code that administers these tests to millions and millions of kids? And if any of them score high enough, can I not, quote unquote, make the market with credible buyers of those services? And that's what we built. It was very successful. It was a global company, and then we sold it 10 years later. But it made me open an office in Beijing and have a huge Chinese team, along with an offices in India and San Francisco and other places. And it taught me a lot about how to actually operate in China. I had to also learn Chinese, which was a helpful side effect. It's really bad now. But what is true is that my two kids are fluent in it, because they were little and they came with me and stayed with me in Pudong in Shanghai. And being little, they didn't know that it was supposed to be a tough language, so they just learned it, just like any other kid would. So it's the beauty of not knowing. Chai Point is a company that has 250 stores around India. We give Starbucks a very hard time because we are priced 80% cheaper, and we make incomparably better chai than anybody else. And it's remarkably consistent quality, hygienic, good standard. And we've sort of invented a range of robots, which is I hope will be the claim to fame. A line of robots that you could install. It's biometrically connected to your irises. So you can flash your eye at the robot, and the robot will make the tea that you want once you tell it what it is. And you can go anywhere in the country and flash your eye at my robot, and it'll make exactly your cup of tea to taste. It's pretty wild. But those are now, there's 10,000 of them installed across campuses in India. And my hope there is that the connection to China is the robots we designed ourselves, but with help with Chinese engineers in Shenzhen. So that's where we built all the early robots, and we continue to do experiments in both Shenzhen and Bangalore to figure out how to do this better and better. But my dream is now that I want to make a robot that's this size that I can give to any poor kid in India and say, here, set it up on a roadside and make sure that if somebody comes, you serve them their cup of tea and you keep 30% of it. So effectively, it's an employment generator at scale, right? So my new target is at least 1 million jobs. And if I can roll out 500,000 robots, we'll be good to go. So, okay, I'll stop with that. But the idea is that there is, of course, your standard pointy-headed academic scholarship that 5 people read, each paper, some books, which are exercises in reaching the public, and then a lot of interventions, for-profit and not-for-profit companies. Okay, So that's where I'm coming from. But for today's talk, really, this little kind of ratty-looking manuscript is the linchpin for the talk. It's a manuscript. I don't know how long it is. I forgot. I read it a long time ago. Maybe it's 15 pages long, written by Vannevar Bush in 1945, presented to the U.S. president at the time, and it's titled "Science: The Endless Frontier." Right. A remarkably amazing document, still available for anybody to read, and very simple. It basically just says what the title says, which is if you do science, frontiers are possibly expand and open up to you in an unlimited way. And I think those of us who are connected to the sciences, my connection is tenuous through the mathematical sciences, but enough to appreciate it, know that every scientific discovery opens up endless new possibilities. Right? I was talking to my high school friend and professor of astrophysics sitting here, Lilia, this afternoon over lunch. And I think, as the possibilities of better data and better, if you will, and better telescopes peering into the heavens open up to us, there are more and more questions that are left unanswered, right? So science is always opening up this stuff. But Vannevar Bush basically made the case for what became, the way I would describe it simple-mindedly in my own words, is a societal consensus around the importance of science. And absent the societal consensus, you cannot make progress. The societal consensus is this. It is that taxpayers will fund pure science. Right? That's the consensus. Taxpayers will fund pure science, and the quid pro quo is going to be that the science that results will be published and will be in the public domain, right? And any individual in the country, frankly in the world, is free to access those publicly available scientific output, right? And do anything with it that he or she desires. And the incremental value that they create, they're welcome to keep it for themselves. Right? That's the quid pro quo. So we're going to use publicly funded money to make publicly available knowledge, and anybody is free to dip their hand in the jar, in the cornucopia of knowledge, take it out and say, I think I can use this to make something. And if you make it, maybe you get societal brownie points, maybe you get money if you want to build a commercial company, and you get to keep a piece of it. That's the consensus, right? And Vannevar Bush was the first guy who essentially went out there and articulated it. And it was, the post-war era, time for these things to be received well, and that launched America's massive investment in science. That part of that compact is only now being tested under the current President Trump's administration. So we'll see what happens with that, but I'm not going to go down that road unless anybody really wants to. The second part of the consensus was in maybe around the 80s when Senator Bay, Evan Bay, I think, and Bob Dole passed the Bayh-Dole Act. Must have been the mid-80s. I'm looking at Paul, my lawyer friend here from the Carlson School. But the Bayh-Dole Act was really seminal because it cemented the second piece of the societal consensus, which is that if you are an academic, you are allowed to have some property rights over what you came up with, which is a way of saying that you're incentivized to contribute to the public good because, hey, through intellectual property rights, you can keep some of it. Maybe you have to share it with the University of Minnesota or with Harvard College, but you do get to keep some of it, right? So those two things, Vannevar's ratty-looking manuscript and Evan and Bob's seminal legislation really set the stage for a generalized view that we should really invest in science. And that has held firmly true for 70 years, essentially, and has fueled the entire scientific enterprise. What I want to say is that China came a little bit later to the party, but it figured this out, I want to say, in early 1980s and had it fairly anchored by the late 80s. When it began to launch programs that, if you read the Chinese documents, to me they sound just like this, right? Not quite, but just like this. The idea that we're going to invest heavily in science and that university academics and academics should be allowed to keep some of the entrepreneurial rents, if you will, and so on and so forth. Not quite the same way, but the contours of that consensus began to be visible, I think, in the late 80s. And in the last decade, or 15 years maybe, they've really doubled down on the pure science piece of it. I'll show you some numbers that show that the percentage of money that China allocates to science is increasingly being skewed towards basic science over the last 10 or 15 years, which is really the fountain of essentially everything that you see around you is the outcome of some basic scientists who did it for scientific curiosity, not for practical application. So how do we know that that's going to happen? We don't, but empirically, I think that's what's happened most times that people have invested in pure science, that something or the others come out of it. India is even later to the party. It's just starting to get religion around this idea. I'm one of the people who is involved in architecting this new societal, but only one out of several. And I think the sooner that my country of origin gets with the program, the faster will be the growth rate catapulting out to even less poverty than we have right now. What I mean by that is India is going to grow, I can fairly confidently say at 6% indefinitely, given the demographics. It would have to take a catastrophe to stop that. But to get to the 8-9%, to move it out of lower middle income status, you need heavy science, which society is not there around. So that's really the contours of what I want to say. And everything I say from now on till the end are going to be iterations of what I already said. So in some sense, my talk's done. I'll just try to illustrate it in a couple of different ways. I just had to put a ChatGPT picture up. I asked ChatGPT to say, give me a cartoon image of China and India leapfrogging the world. Okay, this is a chart lifted from the World Intellectual Property Rights Organization. It's probably hard for you to see. Really, just look at the part on the left. It is improvements in countries' innovation ranks from 2013 to 2024, over a 10-year period. Let's just say recent 10-year periods, which are the countries that have improved their innovation ranks in the world the most, right? An innovation rank is some cobbled together ensemble of 80-odd metrics that the great and good have come together to say that these are what constitute an innovation rank. So obviously it's something complicated that you're trying to summarize in a number. But for what it's worth, the two countries that have done the best in terms of catapulting themselves forward are China. That's the blue line on the rightmost part of the left panel, the one that looks the highest. And the one next to it is India, which is quite a bit behind, but still ahead of all other 190 countries. So what you see here is China going from middle income to much less middle income, shall we say, not quite high income status, let's say per capita income of $7,000 to $14,000, $15,000 in this 10-year period, and India going from very low income to lower middle income status, 1,000 to call it 4,000, right? But still the two best performers. And I would say to you that it's really this consensus in both countries around science and innovation. In India's case, it's more innovation without pure science. In China's case, it's all kinds of science, and increasingly much more so than even the United States is able or willing to do going forward. And I think there have been a number of decisions made in China in the last 10 years that I think are going to pay dividends for the country the next 30. Whether they are sufficient dividends to offset other headwinds to their growth story is a whole separate empirical question that I have a view on, but is not immediately relevant. Some quick pictures. This is from The Economist. I just lifted it straight out. Share of high-impact papers, science papers, and on the right is a similar number from Nature. Nature computes its own index of important publications. And you can just see China beginning to... India does not show up, because we're not playing in India, we're just not playing in high science just yet. But you see China becoming well on its way to becoming a superpower and eclipsing the United States by both these measures. This is another graph from the same article. It basically just lists a bunch of fields, again done on the basis of analyses of papers published in Science and Nature and other prestigious scientific outlets. But what you see essentially in the physical sciences, just to be very loose about it, in the physical sciences, China is way ahead of the United States now as an ensemble. And in the life sciences, the US is still pretty much further ahead. And that rings true to me. Coming from Boston, which is a life science mecca ecosystem, so to speak, that's pretty visible to me. It's pretty dramatic what happens within half a square mile of my Harvard Square office. Really quite heartening. But this gives you a sense of variation. It's not a blanket story, it varies by field. But nonetheless, it's extremely impressive what's been accomplished with scientific infrastructure. Same thing with patents. This is analysis by an econometrician, a colleague of mine, Josh Lerner at Harvard. What he did was, this is a heroic empirical exercise, actually, to accumulate patents in multiple countries, multiple language sources, going back for decades and decades and decades, and then producing summaries. But the essence of what they did is one page in that paper that's unpublished, that's brilliant. It basically says there are 14 areas of science that are classified as critical to national security by the United States. And they overlap, unsurprisingly, as the same areas that China would consider valuable to national security. And for each of those 14, I just put 6 pictures up here arbitrarily because 14 would make it look even smaller. You wouldn't be able to read it. But all you need to see is that the red line has shot up and the blue line is stagnant. And the blue line is us in America and the red line is China. There is not one of the 14 areas where China is not considerably further ahead. Right? So titles here, actually I can't even read the titles with my 59-year-old eyes. It probably says quantum sciences, clean energy, space technology, advanced computing devices, material science, things like that. So things that you would normally consider to be pretty crucial. But the punchline of this is they're very far ahead. That's really all that matters. Okay. So how does this work? I want to direct your attention to just, so we're used to thinking of infrastructure. If I say the word infrastructure, we think of roads and bridges and dams and highways and stuff like that, right? Just like physical infrastructure like this, we should be thinking about soft infrastructure also. By soft infrastructure, I mean things like intellectual property rights. In this country, we would say rule of law, information environment, sanctity of information, arbitration mechanism, arbitration and alleviating disputes or resolving disputes to some extent. Those are part of the soft infrastructure of a country, right? Equally important, maybe more important than hard infrastructure. And what makes a country work is the combination of the hard and the soft infrastructure. Here I'm looking at a subset of the hard infrastructure, which I just arbitrarily call scientific infrastructure. Because when I look around and see what the US used to do, right, what would be examples here? You would think of course, NASA would be an example of an infrastructure of sort, right? CERN in Geneva, right, would be an example of an infrastructure of sorts. And there are plenty of examples. But the country that has produced the most hard infrastructure in the last 10 years is China. The US is not doing it. In fact, it's getting out of the business of doing hard infrastructure. And that is a colossal mistake. It's a colossal mistake. It will cost the United States, sadly, in the decades to come, after the decision makers who presided over that have long gone. But that's how it is. So what do I mean by this? I'm referring to sort of physical, scientific, infrastructural facilities, testing and validation centers and stuff like that, innovation clusters. And let me show you some pictures and give you some examples. I found this list in a book that somebody had published in China called The Dawn of Big Science in China. So just lifted it out of it with gratitude to the writers. But essentially a list of big new science facilities. So each of these is, I don't know, if you want to fix magnitudes, $500 million in size to put up. So it's not something that a university could put up. Even a rich university would put up easily. Well, maybe it is. But not easily in any case. But certainly it's a lot easier if it's put up by a constellation of entities coming together, which is why you go back to the idea of the societal consensus. You need a consensus for everybody to agree that we should put down $1 billion for this and $1 billion for that, and the payoff will arrive 10, 15, 20, 30 years from now, even later. That sort of intertemporal alignment of incentives between people paying today and our descendants reaping the benefits is one of the hardest problems for societies to solve. Some would say that solving that problem was the birth of civilization in some ways, in so many abstract ways. Here's an example. I just like this picture. I don't know anything about it, but you can tell it's big, right? It's a superconducting X-ray machine for free electrons. I have no idea what it does. But the scale of it is what I'm really fascinated by. This one I do know something about. It's called the Shanghai Synchrotron Radiation Facility. I actually know this quite well. I put up the word supermicroscope just to explain it colloquially. You can actually look at molecular level stuff using this machine in ways that you couldn't otherwise. So let me try to recreate in my mind some numbers from memory. It's about 25 years old, okay? I know it's been operating for 15 odd years, okay, functioning as a supermicroscope. It's open to public, right? What I mean is if you're a card-carrying scientist or somebody who has a legitimate purpose, you could access it. Mostly it's academics floating around, writing papers off it. So I put up the 11,000 papers have been written on it in pretty much every field where you would need a microscope, which is essentially every field. Think all the life sciences, think material sciences, think atomic physics in different ways. So it's 15 years, and it was 5 years to build and 5 years to plan, right? So somebody had the idea, well, actually, not somebody, I know who it is. It's the Shanghai city, the city of Shanghai, the city government, that then petitions the Chinese Academy of Sciences, which is an apex policy-making body, sort of like what would be an analog in the US, like the cabinet. Right? Secretary of this, secretary of that, secretary of this, sitting together and saying, we should do it, we should fund it. We should lend the Shanghainese, the city government, enough money to do this. So from the time that somebody proposed it, my guess is it was local scientists in Shanghai and the city government, proposed it to the Chinese Academy of Sciences, some iteration, some approval. Ultimately, the Academy of Sciences has to approve it. It's like a 5-year process, 5 years to build, 15 years to run. And it probably cost, in those days, 25 years ago, $200 million, $250 million. I would be shocked if this hasn't produced $20 billion worth of value. I'm making that number up, but I would be shocked if it's less than that. I mean, the number of things that would come out of this. Right? By the way, does anybody know, like in the United States, for $1 that you invest in science, what is the estimate of value created for US society in the future? Any numbers? Throw out a number. If I put $1 into science today and I do the thought experiment, what value would arise for society? Obviously, there's some assigning of numbers to arbitrary things in this exercise. What would that number be? Anybody? Shout out some numbers. 100? Any others? No guesses? My Harvard classroom shouts at me all the time. These Minnesotans are polite. Must be the Midwest. So the average multiplier is about 17, okay, in the United States over a long period of time. It's a great deal. You put $1 into science, you almost certainly get $17 over time. For some outstanding projects, what's a good example? Let me think. Human Genome Project is a good example. That multiplier would be 150, 200 even, right? Leave those aberrations aside. On average, you should expect to get enormous value. And that's just counting the United States. And of course, science produced here is going to be valuable everywhere, right? So this is a good deal, right? The only problem is we got to get the scientific establishment, the bureaucrats, the policymakers, the congressmen and senators to agree to put $1 billion into science today so that some future descendant will get the benefits of it, like 10 years, 20 years down the road. That's a tough one, right? Which is why you go back to the idea of consensus. You don't have that Vannevar-Bush consensus, no chance, right? And so fashioning that consensus to align intertemporal incentives, to invest in long duration, slow gestation projects that are fundamental to the future of all societies is the challenge for society. Right? And science is the instrument through which I'm choosing to make that point. Okay, I'm going to talk about this company that many of you would have heard of, BYD. It's the world's biggest maker of electric cars. By the way, the cars are far, far better than Tesla, far better. And actually, there's a car even better than this. The Xiaomi car is even better than this one, and much cheaper. The lowest end BYD car, I think, I don't know, I haven't checked it out lately, is in China is probably not more than $7,000, $8,000. What's the lowest end Tesla? $30,000, 40, something like that, right? Which is why we have protectionism too, because if the Chinese came in here, our car industry would be in a hot mess. But this is a good example. I happened to visit BYD in the early 2000s. I can't remember when. I want to say 2001, 2, 3. Happened to go to it, and the founder was not there. It was a small company. It was making batteries in Shenzhen, and but even in those days, what I remember, it's very foggy, but what I remember the showroom. There was a toy car there, and I remember asking, "Why is there a toy car here?" Because it's a battery company. They said, "Oh, we'll be a car company someday." I thought that was pretty cool, right? In 2001, and they didn't start making cars until quite a bit later. Very science-oriented. But what I want to highlight here is, and I'm going to show you 2 slides. One, I organized it as public infrastructure on the left to be leveraged and co-developed, and milestones achieved by the private company. BYD is a private company. There's an entrepreneur who started it. It's built up. It's probably got, I should know these numbers, 70,000 employees now around the world. It's by far the world's biggest maker of electric vehicles. But there's an interplay between the scientific infrastructure that in this case has created the city of Shenzhen and by BYD, right? The private entity. And that interplay is what Vannevar Bush and Bayh-Dole triggered in America. And the Chinese looked at this and said, that's what you're gonna do. And so that's really what the process that's rolling out, while we may be losing faith in that process ourselves, which is sad, but that's another story. So what are examples of this? Many of the rules in Shenzhen and Guangzhou and Guangdong province in general were done jointly between the party offices in those provinces and firms like BYD. Not just BYD, there's Huawei and ZTE and a whole bunch of other tech firms there who all collectively come up with the rules, right? So that rule formation is really like the creation of the soft infrastructure that is going to allow scientific inquiry and then the dissemination of that scientific knowledge into other places. BYD invests heavily in the local university, Hong Kong University, which is one of the local universities across the way from Hong Kong, Shenzhen. So much so that, I don't know, I mean, the numbers are quite staggering, investing almost, hundreds of millions of dollars into Hong Kong University to upgrade its scientific facilities. And then there's a dynamic interplay between the scientists and the company, which is again what you want to see both in the generation and the dissemination of know-how. Let me put up a different, oh yeah, so this is a timeline. So you can, I just tried to array what I remembered and what I could find in the public record about, just as a way of communicating it. So this is over 30 years, right? And you can see policy support early on. The world's first mass-produced plug-in hybrid, done way before it was coming out in mass-produced before it was coming out in Japan, I think. Electric buses, first pioneered at citywide scale in Shenzhen. I watched this happening in other cities around the world later, much later, Santiago in Chile, for instance. And it's really a bear to take an existing transportation system and redo it for electric transport completely. And then huge investments in Hong Kong U, which I find just really, really, really cool. But the point that I wanted to make here is this one, that there's almost like an interplay between creating public infrastructure and then leveraging it, and the state, the city, and the private entrepreneur are in a symbiotic coexistence to get that done. That's the consensus, right? Okay, here's another one. I created a graphic. Actually, I did. My RA did. It's this is pretty good. This is high-speed rail, right? So anyone take the Acela, the Amtrak Acela in Boston, New York? What's the top speed? Yeah, it's 160 kilometers or so, or maybe off that, right? So this is twice that, right? The median high-speed rail in China is 2 times the fastest high-speed rail in America. So that should give you something to think about, right? I think the peak speed, the peak average speed across all high-speed rail in China today is about 400 kilometers per hour. And the target in the next 5 years is 650 kilometers per hour. And it's really unbelievably cool how it's happening. So I won't be able to read it from here with my eyes, but I think that just says that the first line is like 2008. I'm guessing it's from the arrow Beijing-Tianjin, probably, a very short stretch. What is that? That's the Beijing-Shanghai line, right? So that's a longer, very profitable line. It was a big deal to make a line that actually was fully profitable on an accounting basis, right? And this was the first line that was profitable on an accounting basis, probably anywhere in the world. I like this one. There was a lot of science in this. It was the first sort of high altitude line in, I think, in Gansu province in the west, in the mountainous areas. You get the idea, right? It's just, so what do you take away from this? This whole thing started, actually, interestingly, from an academic paper, okay, which I didn't know about. It's an academic paper by some guy in some obscure university, right, who was modeling, simulating the interplay between high-speed rolling stock and the material of the track on which the rolling stock is going. But rolling stock is just the wheels, right? The wheels of the train. But you can imagine that when you're going at extremely high speed on metal, you have metal deformation going on. You need a lot of material science. You have wear and tear. You have differential responses to temperature. Very complicated problem. But way back in 2000, somebody's sitting there writing academic papers. Someone picks up this idea and says, this can be the basis of high-speed rail, right? And that triggers the policy-making process. Now, it's not that this sort of thing hasn't happened in my backyard in Boston. I see it once in a while. Right? Someone, for instance, someone's doing stem cell, organ, whatever, regeneration and things like that. They will have to go out and generate the rules to make it acceptable in society. I'm not saying that this is something uniquely Chinese. I'm just saying that you're seeing it happen at speed and at scale. And it's really dramatically transforming what was once a poor country and is not one now. So that's the genesis. It's an academic research paper. And then there's a lot of partnerships between the academy and the state to fund it, to make this happen. Okay, I won't belabor this. How are we doing on time? You good? Okay. Okay. I looked for a schematic of who sets the rules in China, and I found one and I decided it was wrong. So I adapted it. But this is my adaptation of this lovely gentleman's schematic. And the adaptation I put was to add so you can see it's self-explanatory. I put the Chinese Academy of Sciences up there, which is really this like super all-powerful entity that calls the shots in many ways. And it itself has a lot of national labs under it, and a lot of universities affiliated with it. And it's competing with the Tsinghuas and the Beidas of the world, the Fudans of the Beda-speaking universities of the world, for talent and so on. And there's been a lot of criticism in China and policy discussions about its role, saying it's lost its way, it's doing too much stuff. It really should not be doing the things that kind of standalone universities are doing, like Tsinghua or Fudan or something like that, that it should be focusing on things that others can't do. And what are those things that others can't do? It's those mega projects that cost $1 billion each. Because take the really long horizon, do the things that private universities can't do. But it's been the engine of a lot of this growth, I think. The graph on the left here, one of the graphs, I think the blue graph on the left is basically showing R&D divided by GDP, right? Showing that the amount of resources that society is pouring into R&D is rising in a secular trend over the last several decades. And the red line is saying that of the money that's going to R&D, what percentage is going to basic research? And that's also rising. And that I think is an indication of the cementing of the societal consensus, right? Because the more you believe in the long-run value of science, the more you're willing to say, let's invest in, a paper on I don't know, since we have an astrophysicist paper on astrophysics that may pay off 40 years from now, right? It's not going to pay off today, but something about satiating our curiosity and understanding so many things about the universe is bound to be useful at some point. But as you become confident that that's a good idea, and I think in this country we're losing our confidence, and in India we haven't yet found the confidence, but China is in that sweet spot where it found the confidence and is riding it for all it's worth. The more you will end up putting into basic research. Okay, I'm going to switch to the other country. This is the Economist cartoon of Mr. Modi in a tuk-tuk or an auto rickshaw leapfrogging the world, right? It's not my ChatGPT attempt, it's probably the Economist. But I'm going to talk about a little bit in the next, 10 minutes or so, about the emergence of a consensus, as I see it, as an observer, but also a small participant in forging the consensus in India. And it's very, other than basic science, it's kind of working, right? But it's in the early days, but it's not working when basic science is concerned, because we just can't seem to get energized around the idea that we are where China was 15 years ago. Okay. And I think the roots of this problem go back to the 50s and 60s. So India got independence from the British in 1947. We had a very charismatic first Prime Minister, Jawaharlal Nehru. I love reading about Nehru, fantastic things that he did. Mostly he believed in democracy, even for a very poor country, which nobody else was willing to think would work. But he made a few mistakes, with the benefit of history teaches us. One of the things that he did was he separated research from teaching. I was making it very simple. He basically separated research from teaching. He said, if you want to teach, you're going to set up these amazing institutions, right? That the IITs, the Institute of Technology, are MIT-like places, and the Institutes of Management. We have Accenture probably from the IIMs. Amazing teaching institutions. But the genesis was never for them to be research powerhouses. The research was put into these large national laboratories. There's a network of laboratories called CSIR, what does it stand for? Center for Scientific and Industrial Research, which is a network of 45 laboratories that have billions of dollars and tens of thousands, maybe hundreds of thousands of researchers that basically do not much because they live in their silos, right? They don't connect to problems. There's no chance that somebody in CSIR is going to be working on a high-speed vibration simulation for a high-speed rail in the future, and that somebody's going to see it and something's going to happen. That soft tissue hasn't been created. And the genesis of the lack of creation of that soft tissue was that Nehru, way back when, said, research people, you live here. Students and teachers, you live here. Okay? And that has just proven to be, I'm just saying it very simply, that has just proven to be the most insidious barrier to getting this fertile cycles of mutual reinforcement going. Right? To keep plowing money into science, you need to see things happen. Otherwise, why would the taxpayer support it? Why would the politicians support it? And if you've told the researchers, you sit in your nice office, actually the offices aren't even nice anymore, sit in your offices and produce papers, and meanwhile these other people are going to go do practical things, you're going to get exactly what you set up, which is meaningless research, not very high quality, and no spillover into science. We are still fighting that 70, 80 years later. And a lot of the stuff that I've been doing as part of the pro bono policy process from the outside is fighting this. Frankly, with no effect so far. So that's the core of the problem. Finally, in 2020, we managed to get something called the National Education Policy enacted in Parliament, right? Which is a great first step. It is the first document in independent India that says that what we did that time is all wrong. Of course, it doesn't say it's all wrong. No politician would admit that. But it does say that research and its applications have to work hand in glove in synchronicity of some sort. There are some pockets of success. The space sector is, I think Indians are justifiably proud of it. We managed to put something to orbit the moon for $50 million. Sorry, to orbit Mars for $50 million. For $50 million, you couldn't buy a screw at NASA. Right? Actually, for the first time, a country was able to have something reach Mars and revolve around it successfully on its first attempt for no money. That's pretty awesome. For no money. For less than what it costs to make a B-rate Hollywood movie. Managed to put something on Mars. So there are genuine achievements here. The picture in the middle is a heavy launch vehicle. I mean, basically what's happened here from the 60s onwards is, I like the picture on the left. It's the first rocket that India tried to shoot up. They had to borrow the rocket from someone because they had no rocket or no satellite. But they wanted to put something up there so that they could start doing weather applications and things of that nature. So they borrowed a rocket. There was a bicycle. Somebody rode the rocket on this bicycle at the first launch site, borrowed a satellite, put it up there and said, look, it works. That's the launch of the Indian space industry. Then they built satellites, then they began to launch them. Then they orbited Mars, landed on the moon, blah, blah, blah. So now I think it's probably only one of four countries that is able to do lunar, interplanetary, and heavy launch in the world. I mean, the others probably being US, Russia, and China, I'm guessing. So it's there, but it's there on a shoestring budget, and it's there on no real deep-seated belief in fundamental research about science. Right? I mean, the ratio of R&D to GDP in the US is 2%, something like that. In China, it's probably 2.5%, 3%. Korea is 4%, Israel is 4%. India used to be 1%, it's now 0.4%. So we're going the wrong direction. GDP is going up, absolute amount of money going to R&D is going down. And all I can say is that we're celebrating the fruits of past science and not putting the seed corn in. Nonetheless, it is a success story. Okay, so this is what, when Shri and Ax and I were kids in India, this is what I will call, the Indians call it a ration shop. It's a fair price shop where you can get subsidized food, and everybody got a ration card, right? And you were entitled to so many bags of, rice and so many bags of wheat in a month, and you went and got it, or somebody got it for you. And this is what it looked like. It looked like a mess. And you had this little book that the guy would sign in and say, you got your allocation today. As you can imagine, it's full of fraud in every possible way. There are fake books. There are people who get denied their free rations or their subsidized rations. There are people who double count and take money. There are fictitious individuals and so on and so forth. Right? This is what a book looked like. Right? That's a real book. So this has been replaced by something called Aadhaar. I'll tell you what. It's been replaced by the following. It's been replaced by what I'm going to describe is a digital backbone for the country that has leapfrogged every country in the world, right? Including China. It's completely leapfrogged China. It's what makes my tea robots be able to, as you walk past with your iris, I'll make you a cup of tea without your knowing it. Right? And it'll be produced at 10% of the cost of Starbucks, and it'll be much better. And then you walk in the other room, it'll happen again, because there is a digital infrastructure that's been built in a decentralized way. And this has all been done since 2009, right? So we're talking 15 years, 16 years from now. The core of it is something called Aadhaar. Aadhaar in Hindi means foundation. So, and the foundation is a biometric ID, which is everybody has a biometric ID. In most places, how do you establish your identity? Like if someone says, prove that you are so-and-so, how do you establish it? Paul is showing me his hand. That means you show me a card, right? Or you have a password or something like that, right? I think India is the only country where you do it with your body. You don't need a card, you don't need to know anything, you don't need to memorize anything. It's your body. You are your ID. And why is that important? Because half the country is illiterate. functionally illiterate. And so people can take advantage of them. What is this notion? I'm looking at the lawyers in the room. Habeas corpus. You have to produce your body, right? That's a central idea in whatever law and human rights and so on. What if you go to a police station to lodge a complaint and there's no ID possible and you don't have an ID, and you file a complaint and the policeman says, I'm not obligated, you don't exist. You have no way to prove that you exist. So it is so fundamental, this idea of identity, right? That in India we've gone for 60, 70 years with no way of proving identity, right? Resulting in rampant abuse and people taking rampant advantage of so many others. Now for the first time, all 1.4 billion citizens, or residents actually, of India have a unique biometric ID that is essentially hack-proof. Until we have quantum computing, it's hack-proof. After we have quantum computing, that'll be a different story. So we invited Mr. Gates to come to India in 2016, and this is straight out of the speech that he gave to whatever, the great and good, saying that no rich country has ever done this. This is going to be the foundation of the next powerhouse in some ways. I actually believe this. I think if we can just get around to investing in basic science along with this, we will eclipse everybody else. We, meaning the Indians, will eclipse everybody else in a decade after that. So in 2016, he said the next several years, India will become the most digitized economy, not just by size, but in every possible way. This is true today. It's true in 2025. So it's a remarkable achievement, and it's in most people's minds a technological achievement, but it's not coming out of basic science. It's coming out of people like me and other techies getting together, mostly in Bangalore, and saying, we can do this. Let's just rewire the whole country. And it was done in a pro bono way with a bunch of characters, like myself, essentially volunteering time, going back to 2009, led by a guy named Nandan Nilekani in Bangalore, putting this system out in place. And now layers and layers of this called the India stack, right? So that graphic on the top left is the Aadhaar, the base layer, so to speak. And the India stack is a series of layers on top of it that allow for, I wish I could read it, I can't read it. What's it called? Consent layer, cashless layer, paperless layer, presenceless layer. So everything can be done digitally. If I go to, what's a use case? If I go to a would-be employer, right? In the old days, they would say, where were you educated? And you would say, I was educated at the University of Minnesota. And then they would say, show us proof. And then I would have to get the transcript. And I would electronically send the transcript. Or I would make a photocopy of it and scan it and send it, right? Here, what you do is, it's all in the cloud. Everybody's data is all in the cloud, all documents. So you say, if Paul asks me, prove that you have these qualifications, I basically say, please share qualifications with Paul, right? So I send a message. So on the right is the data consumer in that example. Paul is the data consumer because he's interviewing me for something. He asked me for something. The so-called consent manager, this is the architecture of the system we've set up. The consent manager tells the user, hey, somebody needs to access your data. Right? So consent manager calls me and says, Paul needs to access your data. I tell the consent manager, okay, give it to Paul. The consent manager then goes to the data provider, which is a cloud repository where that data sits, where a digital facsimile of my transcript sits. The data provider then releases it to the data consumer. And then that data is wiped out after the authentication is done. Right? It's all digital. Everything is digital. Every single thing is digital. Every payment is digital, right? Everything is plug and play. And one thing I forgot to say, which is super important. In the United States, I think we made a mistake going back a long time, inadvertently, which is we allowed a bunch of tech companies, including the aforementioned Bill Gates, right, but also Amazon and Facebook and so on, to become de facto tech monopolies. Right? And now it's fair to say that society is struggling with the amount of economic and political power that these companies have amassed. Lina Khan, the last very young chair of the FTC, basically tried to rein them in by reinventing antitrust doctrine. Antitrust doctrine, the way Lina Khan is presenting it, is very different from the way Paul studied it in law school. It starts from different fundamentals. It says, price is not going to be the be-all and end-all of whether you are being abused in an economic sense. But we're doing that because we have this excessive concentration of power. Same thing, by the way, happened in China. Basically, Tencent and Alibaba and Baidu, now ByteDance, have amassed a lot of power. Now, in the Chinese system, which, as you know, is more top-down, the party arrests the excessive concentration of power through fiat mechanism, through simply asserting that you can't do that, and asking Mr. Jack Ma to go hang out in Tokyo for 5 years and be a good boy before he comes back. That's the way China is trying to control it. In India, we saw this 10, 15 years ago and said, we don't want to do that. We want all tech infrastructure to be publicly accessible, just like anybody can drive on that road. Right? The digital highways should be publicly accessible in a way that will not allow for the concentration of power. So in India today, if you, I don't know how far it's been implemented, but the idea is if you go on Amazon in India and search for something, that search query will automatically be sent to all platforms, not just Amazon. It'll go to everybody, and vice versa. Because it's all digital plug and play, everybody has to comply with the infrastructure. So the idea now is that to really amass profits, you have to do something really incremental about this. Okay? I'm trying to give you a flavor that everything, that's why I put it up here as ease of life. It's not ease of doing business. We say ease of doing business, we say ease of doing science. We are trying to drive the tech infrastructure in the country for 1.4 billion people in a fundamentally new way to deliver ease of life. Okay? Will we get there? I don't know. And the line below is from my friend Nandan, who's really the architect of all this, the inspiration behind it. From data darkness, right, where so little data was being used in a poor country like India that didn't have the infrastructure, to a situation where each individual's digital exhaust is a monetizable asset. What does that mean? If you're a poor person, right, you don't have, and you go to a bank and you say, I need to take a loan, the bank's going to say, what's your collateral, right? And you're going to say, I have 10 bananas I need to sell today. That's my collateral. Nobody's going to give you a loan for that. So you're stuck in that cycle of poverty. Now, because everything is digital and you're using consent managers, just by the act of living and getting through a day, you're producing digital exhaust. You're leaving digital footprints. And patterns of digital footprints over time can allow a would-be partner, collaborator, financier to say, I understand the patterns in that pattern of life. This guy looks like a reliable person. Looks like he gets up every day, he goes and stands in that street corner, he works for 6 hours and he comes back. That sounds like a monetizable asset. I'll lend him $100. Right? He's not going to the liquor store to go drink away his stuff. He seems to be reliable. So the digital access is now a monetizable asset, and it is totally unlocked economic power, right? Totally unlocked economic power. And we're just in the early days of that. So imagine instead of 100 million people powering the world's third largest economy, if you suddenly had 1.4 billion people powering it, that would be a nice thing. That's the idea. So this is like system-wide rewiring. Okay, I'm going to stop with this example. Really what I'm trying to say is that there is good technology and science happening, and that rollout in India is happening very differently from the US and China. And that's the point I wanted to make, is that really this idea, so in India you have a societal consensus that has not been reached in the full sense. But bits and pieces of it that have been reached have been pushed to incredibly far extremes within the constraints of that, through whatever, luck, effort, something, some happy accident of things. Well, what's left is to get the Indian government to believe that basic science is to solve that intertemporal problem, intertemporal alignment of incentives problem between this generation and subsequent generations of investing in basic science that will not pay off for a long time. That's work in progress. Okay. By the way, this India Stack, there's a nonprofit created by the Rockefeller Foundation. we all need to take the India Stack and make it available free to the whole world. So you've got like 30 countries now implementing it. It's run by a close friend of mine with whom I had started a charity many years ago, Madhukar. He's the CEO of it. I don't know, maybe 50 countries are trying different bits and pieces of the India Stack to roll out, including, by the way, Japan and France, saying we can take a piece of this and put it in, right? And you can imagine it's tricky. If I were to come in here to the United States and say, put the India Stack, there would be a fit from all the privacy people saying, oh, privacy will be compromised. Actually, privacy is not compromised. There is no known instance of privacy being compromised in this because of the way the code is written, until, as I said, quantum computing comes around and everything can be hacked. But for now, there's no such thing. But we're trying to roll it out. I'm not going to talk about that. Okay, let me end with New York. Okay? Little switch. But I want to say that everything I've said applies to New York City. Okay? Just like you need a societal consensus in a country, you need it in microcosms, right? So this is a picture of, I was talking to Shri about it earlier today. It's a outfit that I bumped into. I had no role in its creation. It's a fantastic idea. Basically, the idea is how would I say it? It's a deep tech incubator that started in Brooklyn, New York. And what it does is it creates a consensus around science between scientists, entrepreneurs, and public policy makers in the city of Brooklyn. Okay? Just like I was talking about Shenzhen examples, it applies to Brooklyn as much. And this guy, the founders of it, realized that the Brooklyn Navy Yard was an unused facility. It's actually a beautiful facility. In the 1940s, 1930s, 1940s, the submarines were made there for the war effort. And then it was left unused for decades. And so they went to the city of New York. Mike Bloomberg was the mayor, and I think Andrew Cuomo was the governor at the time, and said, hey, listen, we can convert this dead space into something cool. It is super cool. You walk in here, it looks like this height, right? With a sort of industrial chic facade to it, lots of plants everywhere, amazingly high-tech equipment that would not be available in New York City, that attracts all the scientists from Columbia, NYU, CUNY, SUNY, Penn, Princeton, everybody gravitating there and say, this is a place where we can make cutting-edge devices that would then be useful. And then these guys make the match to the world's largest corporation. So there's an exit for the scientists and this to happen. But really the consensus I wanted to point to is that society is just like in Vannevar Bush's example of that ratty 1945 manuscript. He said, taxpayer has to fund science, right? Here also the taxpayer is funding this by giving access to the entrepreneurs to unutilized, already taxpayer-funded physical infrastructure. This thing was so successful that Bill Ford found out about it and put, I think, almost $1 billion with a B into redoing Michigan Central, the dilapidated train station in the center of Detroit, which is a stunningly beautiful property, right? And that has led to a renaissance in that part, and New Lab is right in the middle of it, trying to forge a connection between this. So this idea of pockets of unused infrastructure, right, science and private entrepreneurs is just a simple idea that can roll out in so many different ways all over the world. So I think what we're seeing happen in China, to the credit of the Chinese, and what we're seeing India struggling with to birth in its own way, is no different than what I'm seeing in New Lab. This particular thing has been rolled out across, I don't know, 7 or 8 cities around the world now. Same idea, for unused infrastructure science in this. So, this is my last slide. The societal compact between state, universities, entrepreneurs provides a lens through which to view the evolution of these ecosystems. China's compact dates back to a tentative start in the mid-1980s, and it's accelerated in the last 10 years. And I'm just awed by it, and I think it's fantastic what the Chinese are doing, and I hope they keep doing it. And India, hampered by some unfortunate decisions in the 50s, has started to get religion around this, but not quite. And we're trying. Thank you so much for your attention.
Can I take a seat?
Sure. Am I on this side? Yeah, I'm on this side.
So thank you, Tarun. We're now open for questions. I know there are folks with mics going around, but maybe before we even, please think about questions, put your hand up or circulate the questions to us. But maybe before we even get there, I wanted to kind of start off with a question for you,
Okay.
which is, you talk a lot about consensus, especially the Bush consensus, the Vannevar Bush consensus that really propelled innovation in the United States in such a significant way. Now, I know you're trying to suggest that it's a similar consensus that has emerged in China, but does China need consensus? I mean, it's an authoritarian state. I mean, why does it need government and, society to agree to whatever it is that they want to do?
So Shri, I think it's a fair question, but I think the idea that an authoritarian state does not need the acquiescence of its citizens is flawed. It does. Okay. It has short-run instruments to force other actors in society, but in the long run, it's just very hard even for an authoritarian to last. And if you're trying to I guess what I'm thinking is if you're trying to put in place either physical or soft infrastructure that lasts decades, then I think simply relying on authoritarianism is not likely to work. I think even an authoritarian state is going to be very mindful of public opinion, as the Chinese state is. Right. The Chinese state is hyper-vigilant, is far more vigilant than Mr. Trump's America at essentially policing every action. I mean, have you been around? You've been around Beijing. I mean, there's cameras everywhere. I mean, you couldn't walk down the street with your picture being taken 100 times. So, and the reason is that I think the Chinese state is sensitive to what its citizens are thinking. So that's how I would think of that. But you're right, in the short run, I mean, the Chinese can force. I mean, you saw what happened to Mr. Ma, right? That was sort of and you read the Western press, so you read the Chinese press every day. I mean, there's all sorts of interesting people who suddenly are not around for a while, shall we say. That's a way of enforcing consensus, I would imagine. I don't know, never having been subject to that, I don't know. But, though I have been escorted away from the stage a few times.
Well, any questions? Yes. There's a question from Tom.
The difference here, and what do you think about the Bush administration's, the Trump administration's huge amount of money they want to invest in tech, via some of the entrepreneurs? It's very unclear where this money goes. It's a huge amount in contrast to what it cost DeepSeek to develop, in some ways, a better system. So how would you comment on these recent examples of the openness doctrine?
So, I'm not how would I say this? I'm not a machine learning specialist, right? But I can read the math papers and understand the intuitions. That's the level of my understanding. My sense, for whatever it's worth, and please, I'm not an expert in this, but my sense, for whatever it's worth, is that we are doing what societies usually do when something new and shiny happens, which is we're chasing like crazy behind it, and we're just trying to run faster and faster on a set of treadmills that somebody invented a treadmill, we're all going to race on it. And everybody wants a slightly bigger, slightly smoother treadmill to do the same thing. It's not at all clear that large language models are the way to go. I think most people at this point would say that it's pretty clear they're not going to result in AGI, artificial general intelligence. Actually, I shouldn't say that. Maybe most people wouldn't agree, but I certainly don't think so. There was that Facebook guy who just quit. What's his name? I forget whatever the name of the chief scientist was, who I think had the right idea to say that in the end, it seems intuitive that approximation to artificial general intelligence will come from not just text-based systems, but combining multiple sensory modes of forming some sort of intelligence. Why am I saying this? I'm just saying this to signal that we are at such early stages of that I don't even know how to really think about it. other than to say that there are many ways to be creative, right? I mean, for instance, there was a period about 2-3 years ago when there were these frontiers being developed by computer scientists saying, what's the trade-off between size of the data set and amount of computing power that you need, and by extension, how many trees do you need to destroy to power that query, and having smarter algorithms running on the data set. So maybe can you have a smaller data set and less compute with a slightly different algorithm to do, and I see DeepSeek as an example of just that. Right? Of course, we don't know what actually happens within it, but it seems reasonable to assume that it's basically a better algorithm running on a smaller data set. So I think there's going to be many. I'm imagining a large tree of possibilities with many branches and sub-branches, and I'm imagining the LLMs to be one of those branches, and we're all standing on that same branch, and it'll take us some distance, and it's already pretty cool. I could make those 2 nice cartoon pictures using ChatGPT, so we've clearly advanced a great deal, but I think it's very early days.
So I have a couple of questions here, and I'll try and collapse them if I can. One is, how does Silicon Valley fit into the picture of Chinese and Indian innovation? Does it?
Silicon Valley definitely fits into the Indian system.
Right.
Very, 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 very intimately. There is an extremely, how would I describe it, tight sort of pipe between the two countries, between Silicon Valley and Bangalore, of entrepreneurs, particularly tech entrepreneurs, going back and forth, being sort of going through sort of baptism by fire in some entrepreneurial journey in the valley and taking it back to Bangalore. And at this point, Bangalore itself is self-sustaining. It's doing its own thing. They're second and third and fourth generation entrepreneurs. What I mean by that is people who've done 1, 2, 3, 4, 5 companies and have set up, just like we saw with Fairchild Semiconductor and Intel and so on. Somebody did something, others spun off, they then did things, their progeny spun off. So that's now become quite old hat, and it's very intertwined with, I was part of the team that launched the very first venture capital fund in India called Westbridge Capital, which really, the name tells it all. It's Westbridge. It was San Francisco. It was in 1999. It was between San Francisco and Bangalore, and it still exists. It's a wildly successful firm. So between Silicon Valley and China, my hunch, I mean, I'm sure that same thing exists. I'm just not as plugged into it. But I think one thing that definitely the Chinese have done infinitely better than the Indians is tap into Chinese talent, right? And bring the Chinese talent back and make it sort of align with the incentives of, and many of my friends are, I can think of at least, 25 leading applied math economists, scientists, physicists of Chinese origin in the top 20 universities in the US, let's say, who have functioning labs in 10, 15 universities in China. And somehow they've aligned it so that it's okay with their host institution for them to go back and forth. India has just completely failed to do that. In fact, just 3 weeks ago, I was in India with the Prime Minister and other ministers, basically trying to make the case that given that American science is being cut back, this is a great moment to attract some of the people. I wish I could say I'm optimistic. Not so.
No, I mean, that's a good point to which to sort of, there are a couple of questions about India here. So one is this idea that, achieving this consensus is very hard when there are poverty needs to be alleviated, when poverty, first of all, needs to be alleviated. So investments have to go into poverty alleviation in real time, while the large long-term investments in science are have to be made simultaneously. How can India finesse this dilemma, do you think?
I wish I knew. But all I would say is that was definitely true for the Chinese.
They did manage to do that.
Yeah, 20 years ago. Now, this is where maybe being a top-down sort of society might work, because if the China Academy of Sciences or the Politburo decided that this was a good thing, then in the short run, they could certainly orchestrate it. That India is less able to do because 4-year electoral horizons are very salient in the minds of any politician. No, it's a huge challenge, and I think the future of poor countries. One of the things we didn't speak about is this idea of inter-country and intra-country inequality. Right? Intra-country inequality. I think both the Chinese and the Indian experiments in very different ways are dramatically addressing the worst poverty situations and alleviating it. But there's also inter-country, right? If, for instance, some of the heavy science investments continue to happen in just 2 or 3 countries, I think the gap between those 2 or 3 countries and other countries is going to be really massive. It's a different form. It'll be a scientific colonialism world, as opposed to the old type of colonialism where you had the European powers going and capturing port cities and trading rights and so on. Here you'll have all the knowledge concentrated in 2 or 3 or 4 countries, and then it's curtains for everybody else. They'll have to deal with the crumbs. It's a very scary thought, and I use that thought in India with everybody to say, really? Is that how far behind you want to be in the next 10, 15 years? But the dilemma that the person is asking about is real. I don't have a solution. I don't have a
You don't have an
solution.
answer. Just a quick answer anyway. I've got a couple of light questions here. I think we're running out of time, I suspect. So maybe one, somebody wants to know, have you taken a chai tea shop out of India? We would love it here at the University of Minnesota. Has a large number of Indian students who, and perhaps Chinese students who would love to have some chai as well,
So here are 2 interesting statistics. So we do have one store that's opening in Muscat Airport in Oman and one maybe in Abu Dhabi in the United Arab Emirates. But really the real answer is we meaning Chai Point. I'm a co-founder of it, so I'm saying we brew 1 million cups of tea a day. Okay, we're probably one of the biggest consumers of milk in the country daily. We're the biggest robotics company in India now, making these robots. But even with 1 million cups of tea, we are 1% of consumption of tea that we have measured outside the home. I'm using the words carefully. Most tea is drunk inside the home, so we're not even counting that. If we are 1% at 1 million, I'm saying there's 100 million cups of tea drunk outside the home every day. That is surely an underestimate for 1.4 billion people who drink multiple cups of tea a day. So after all this work and robots and 10 plus years, we're still at 1% of the available market. It just doesn't make sense to go anywhere else.
Huge growth potential right there at home, so that makes a ton of sense.
It's the scale, yeah.
Yeah, so with that, I think we'll...
Okay.
We have a small
Okay, thank you.
for you.
Thank you very much. Yeah.
All right, thank you so much for your kind applause and thanking our speakers, and I appreciate the assistance from Dean Zahir. The development of equitable and peaceful and sustainable U.S.-China relationship remains crucial. Solutions cannot be reached without sufficient mutual understanding and multifaceted bilateral collaboration. We are thrilled to partner with you to build U.S.-China bridges, and we thank you for coming tonight. Enjoy.